Alright guys, I want to make a quick video here showing you guys how to do a parametric analysis. So part of your final project is going to have you doing two different parametric analysis. Alright, and that's where I want you guys to change something about your model and watch what's happening to those uh, particular variables of interest that you guys have defined. Okay. And what I'm doing here is just showing you an example of a way we can do a parametric analysis. For this example, in our tutorials that we have of a fluid flow through a pipe with this cylinder, stationary cylinder here in the center of our pipe. So we have fluid flow going through this pipe. We have a stationary object in the center. All right, and what we did, or what you did as part of your tutorials, is that you had to change the diameter or change the size of this stationary object inside of the pipe. So you just increased it or decreased it or moved it or something. You made this different. Um, so let's say that I wanted to see how that affects the flow of, or the velocity of the flow through my pipe, all right? And so maybe I wanted to look at the average velocity in this pipe and see how it changed with the shape or with the size of this stationary object, right? So what would I do? I would take a velocity measurement, okay, across this edge, from the edge of this object in the stationary to the edge of my pipe. So I would take a velocity measurement, an average velocity. So you want to use the average velocity or the average of whatever parameter you guys are measuring, because that's going to give you a more accurate reading. You don't want to take a single point measurement. You want to try to take an average. All right, so how are we going to do that? All right, we're going to zoom in a little bit here to give you guys a better look at the details here. All right, and so what I want to do is I want to draw a cut line across this section of my pipe. All right, and so I want to take a velocity, an average velocity, from the edge of this stationary object to the edge of my pipe, and I want to calculate what the average velocity of the fluid flow coming into that pipe is. All right, so first thing I want to do is come up here to my results tab. All right, I'll click on the results tab, and I'll come down here and I'll click on the cut line 2D. I'm going to add a cut line 2D to my project. That's going to add this cut line 2D in my results section here. All right, and I've gone ahead and opened up the settings section for us. All right, I'm going to use the data set of my study that I have, but I need to tell it where, all right, on my geometry I want this cut line to be placed. Where do I want this line? All right, well, if I look over here, I can see on my X direction, all right, I want this to be approximately about 0.6. All right, so I'm enter that 0.6. My X direction isn't going to change because we're going to draw this line vertically. So my second point in my X direction is going to stay the same. All right, so 0.6. In my Y direction, we're going to start at 0. Okay, so we're going to start at 0. And it looks like we're going to go somewhere around, I don't know, maybe 0.1 here. So we're going to start at 0. So that's my first point. And we're going to go from 0.1. All right, keeping everything else the same in the settings. I'm going to come up here and I click plot. And as we can see, Comsol has drawn a line, all right, on this coordinate system that I've defined here. So starting from 0.6 on the x-axis, and then the y direction from 0 to 0.1, we've drawn this line on the x-axis at 0.6. All right. The next thing I want to do is I want to take the average velocity value of all the little data points along this cut line here. All right. And so to do that, I'm going to come up here still in the results tab. All right. And I'm going to click on more derived values. And then I'm going to come in here and select the line average. All right. And now you can see the derived values section has been added to the results, and I have a line average 1 here. Come over here, the data set that I want to select, however, is not my study. All right, I want to select that cut line 2D that I just created. All right, because I'm going to take the average values along that cut line. So I want to pull this drop down menu, select cut line 2D1. All right, and you could change this if you were doing like all kinds of different things. But anyway, you could change the name and so forth. Under the expressions, all right, I'm going to type in U, all right, because I'm going to be taking the velocity measurement. And if I tab over, clicking tab, you can see it fills in the units for me, all right, because we're going to do meters per second, which looks like that's what we have this in. All right, Comsol knows it's a velocity field, okay. And then for the heck of it, I'm just going to grab the pressure. So I enter in P as well, because I've also done, I may also want to do a parametric study analysis on the pressure as well. So I'm doing the velocity, which are the two that I calculated, and the pressure, all right. And so I'm going to go ahead and grab those two and calculate that. Pressure is automatically in Pascal. If you're using something else, make sure you change your units so they follow correctly. All right. So now that I have that in there, all right, and I'm grabbing the data points on the cut line, I can just click evaluate. This might take a second. And now you can see a table is generated down here in my kind of message board here. And this is all my velocity field measurements, okay, for the X direction, all right, which is where our fluid flow is flowing in the X direction, so we wanted to grab that. And the pressure, all right. And remember, so in this example, in this tutorial, we were doing a time series or a time series evaluation. So we're doing a actual time measurement. So if I come over here and look at my time dependencies, all right, I can see that what I'm doing is I'm measuring, or I'm doing this study from 0 seconds to 3.4 seconds at a step of 0.2, and then I change up at 3.5 to 7 seconds and change my steps to 0.02. All right, so that means that at each one of these steps I'm gonna have an average velocity. All right, so I'm gonna have that average velocity. Now it's up to me to then decide if I mean, I don't want all of these average velocities, okay. But you can see we don't change very much throughout the entire study, the entire time. So I could either, choose at the very beginning of the study, say maybe 0.2, right at the initial start, what is my average velocity, or, at some other, interval of time, depending on what you guys are doing. All right. And so I've also then got the actual pressures as well, all right, measurements that I can also talk about as well. So you can actually do both of your parametric analysis at the same time, depending on what you guys are, you know, changing or holding constant. So then what I'm going to do is I'm going to write down, all right, so say I decide that, I'm going to take all my measurements at say 3 seconds or whatever. So I write down my velocity 1.99 is my velocity of my fluid at 3 seconds. All right. And so then what I would do is I'm going to go and change maybe the diameter of this stationary object, make it larger, make it smaller, or do something, to see if I can manipulate the size of this object, and then restation my velocity cut line again so that it's making sense, okay? And then run this simulation again, all right? and get that same velocity at 3 seconds again. All right, and hopefully, say I increased it, so I would imagine that, I don't know, I'm just hypothesizing here that maybe the velocity is going to increase the closer that this object gets to the edge of my boundary here. So then maybe this velocity begins to increase, and so I do this over a very selective series of changes, and so maybe I'm changing this stationary object by 10%, and so at whatever diameter here, we have a velocity of 1.99. Whatever diameter I change this to, I have a velocity of, I don't know, 2.10. So then we're going to have a series of, let's say, 10 different measurements in which I've changed the size of this object and taken these velocity measurements, all right? And I'm going to write those down, systematically, and end up drawing a graph that shows what is my velocity measurement at each change of diameter for this particular stationary object, all right? And so this is what I'm looking for from you guys when you're doing your parametric analysis, all right? I want you to change something in your actual geometry, your object, or something that you have uh, in your project, all right, and then look at how that affects your parameters, all right, that you've defined, all right, in your study. So here we were defining the velocity and the pressure, okay, and that's what we looked at, all right, and we wanted to know what that velocity was as I moved or increased the diameter of this stationary object. And so then I can take those average velocity measurements across this section, in this cross section, and then grab those measurements at each point, write those down, and include those in my report. So hopefully this clarifies a little bit about parametric analysis. If you have any questions, let me know. Thanks.